Good morning everyone. Respected sir, myself Pranim Subba, bearing roll number 20NS0302 of Nancy Government College, affiliated by Sikkim University of BSc Physics Honours. Firstly, I would like to thank our physics faculty member, especially Dr. C.P. Khatagara sir, who gave us this golden opportunity to give a presentation on the topic Method of Synthesis of Nanoparticles. Nanoparticles. Nanoparticle or ultrafine particle is usually defined as a particle of matter that is between 1 and 100 nanometers in diameter. Nanotechnology has enormous potential to change society, and it involves manipulation of objects on the atomic level. The products we build on every atom that are stronger, smarter, cheaper, cleaner and more precise. Nanotechnology is the art and science of manipulating matter at the nanoscale to create new and unique materials and products. It is the study of controlling and manipulating matter on molecular scale. Nanotechnology is a very diverse technology. This is the diagram of the bottom-up and top-down approaches for the synthesis of nanoparticles. First of all, here in figure A, it is a bottom-up approaches. In bottom-up approaches, it implies assembling single atoms and molecules into larger nanostructures, whereas in top-down approaches, it involves the breaking down of large pieces of material to generate the required nanostructure from them. It is also a figure of the bottom-up and top-down approaches of nanoparticle synthesis. Principle of nanotechnology. Principle of nanotechnology is self-contained and unified in presentation. It may be used as a textbook by graduate students and even ambitious undergraduates in engineering and the biological and physical sciences who already have some familiarity with quantum and statistical mechanics. Theory. Now there are mainly the three types of methods for synthesis of nanoparticles. That are physical methods, chemical methods, biological methods. Above from the three, the physical and the chemical methods are considered to be the best to get the uniform size nanoparticles with long-term stability. Physical methods. Physical methods employ techniques such as accretion or pyrolysis using devices such as ball mill, shaker mill or spray pyrolysis to synthesize crystal nanoparticles. Whereas in chemical methods, chemical synthesis of nanoparticles is usually done in a solution with reducing agents such as elemental hydrogen and etc. The advantage of chemical approaches for metallic nanoparticle synthesis lies in its less expensiveness and specificity. Biological method. Biosynthesis of nanoparticles can be achieved by employing microbes or using plant extracts. Microbial synthesis. Microbial nanoparticle synthesis can be carried out by employing different microorganisms such as bacteria, yeast, fungi and ectomocytes which are found in our ecosystem. Their intimate energy-dependent biochemical pathways to process toxic heavy metals into non-toxic form in their microenvironment in response to stress induced by such metals are exploited in this process. Synthesis of metallic nanoparticles. The synthesis of nanoparticles possessing desired characteristics is carried out by employing a pair of approaches which we have discussed earlier, bottom-up and top-down approaches. Now the disadvantages of the synthetic metallic nanoparticles are, in this method, non-uniformity of morphology which implicates the synthesized nanoparticles' physical and chemical properties. Natural and green synthesis nanoparticles. The algae also helps in the synthesis of the nanoparticles. Green nanoparticle synthesis using extract from algae termed phyco-nanotechnology is an emerging area with the expansion of nanotechnology. Algae belonging to the class Cyanophyceae, Chlorophyceae and etc. are being used for the manufacture of the nanoparticles. Colored fixed alenkine is used for the nanoparticle synthesis for plant disease controlled by foliar application of Application. There are many applications of the nanoparticles, but I have discussed only few of them. First of all, nanobots and teeth. The application of the nanotech in the dental field is called nanodentistry, and it is an innovative new technology that has made huge strides in dentistry. There are several new dental products available, ranging from implants to oral hygiene products that utilize this technology. The below figure is for the nanobots and teeth. Tiny electronic sensors. With the current advancements in nanotech, sensors with very minute features can be printed on flexible rolls of plastic. They can be manufactured in large quantities at a very low cost. These sensors can be used to continuously monitor the health of critical infrastructure such as bridges, aircraft, nuclear reactors, etc. Military applications. The military, no matter which country, has tremendous potential in technology. So it comes as no surprise that a major nanoscience research is sponsored by the military and thus focus on military applications. Here in the following diagram, nanoparticles in military applications. It is used as smart materials. Nanoparticles are also used for the intelligent apparel systems, explosive propellants, nanobots, sensors and transducers, aerodynamics and propulsion, and armament electronics and many more. Tiny doctors inside the body. The use of nanotechnology in medicine has been seen huge developments in recent times. Billions of dollars are being spent to research the use of nanoparticles for the detection and the treatment of diseases. For example, we have made considerable research in detecting diseases by creating nanoparticles filled with a fluorescent dye that can latch on to responsible molecules in the blood. The below diagram shows that the nanoparticles in the tiny doctors inside the body. The creation of graphene. Another promising application of nanoscience is the utilization of graphene and other supermaterials using passive nanostructures. Graphene is a nanomaterial that comprises a solitary sheet of carbon of the thickness of one atom. It is extraordinarily hard and has promising properties with regard to electrical conduction. Fight against climate change. Nanoparticles are also used for the fight against climate change. One of the key ways to fight against climate change is by devising newer and more effective methods to produce electricity. Thanks to the advances in nanoscience, we have already seen batteries that can store more energy for electric cars and solar panels that can convert sunlight to electricity more efficiently. Now, another application of the nanoparticles is self-healing. Self-healing can still be considered science fiction for the most part, but with further advancements in nanoscience, it would not be that way for long. Changing the structure of certain materials at the atomic level can give them some very interesting properties. For example, several materials are already available commercially that have unique atomic textures that allows them to repair. The future scope. The future scope of nanoparticles are many, and I have given the 2 points. The first point is nanotechnology is expected to lead to stronger, longer-lasting implants, sensors that can be used to monitor aspects of human health and improve artificial cochlea and retinas. Now, the second point for the future scope of the nanoparticles is given. There is increasing optimism that nanotechnology applied to medicine and dentistry will bring significant advances in the diagnosis, treatment, and prevention of disease. Growing interest in the future medical application of nanotechnology is leading to the emergence of a new field called nanomedicine. Thank you.